Imagine waking up one day, looking out your window, and finding nothing. The sun, our cosmic light bulb, has vanished. No warning, no goodbye note, just gone. What happens next? The consequences would be immediate, catastrophic, and surprisingly complex, affecting Earth's light, gravity, climate, and life itself. First, the most obvious change, darkness. The sun provides almost all of Earth's energy through sunlight. If it disappeared, daylight would vanish instantly. Light travels at nearly 300,000 kilometers per second, so the last photons from the sun would take about 8 minutes and 20 seconds to reach us. After that, eternal night. The moon and stars would still glow faintly, but don't expect a romantic stargazing vibe. Earth would be plunged into a creepy, pitch-black chill. Streetlights and candles might help for a bit until power grids fail. But we'll get to that. Now gravity. The sun's mass keeps Earth in its orbit, a delicate balance between gravitational pull and our planet's momentum. If the sun vanished, its gravitational influence would disappear at the same speed as light, about 8 minutes and 20 seconds later. Earth would suddenly fly off on a tangent, like a car swerving off a racetrack. No more elliptical orbit. We'd become a rogue planet, hurtling through space at about 30 kilometers per second. The solar system's other planets would do the same, each zooming off in straight lines. What about temperature? The sun's energy keeps Earth's average surface temperature at around 15 degrees Celsius. Without it, things would get cold fast. Earth's atmosphere and oceans store some heat, but not for long. Within hours, temperatures would start dropping. In a week, global temperatures could fall below freezing, averaging around minus 20 degrees Celsius. By a month, we'd be looking at minus 100 degrees in many places, colder than Antarctica in winter. The oceans would begin freezing from the surface down, though their depth and geothermal heat would slow the process. Picture Earth as a giant popsicle, not exactly the tropical getaway we're used to. Photosynthesis would stop immediately. Plants rely on sunlight to convert carbon dioxide and water into glucose and oxygen. No sun, no photosynthesis, no food chain. Most plants would die within weeks, starting with crops like wheat and rice. Trees with stored energy might last a bit longer, maybe months, but they'd eventually succumb. Herbivores would starve, followed by carnivores. The food web would collapse faster than a bad sitcom. Some deep-sea ecosystems around hydrothermal vents might survive longer, relying on chemical energy from Earth's interior. But they're a tiny exception. Oxygen is another issue. Plants produce most of Earth's breathable oxygen. Without them, oxygen levels wouldn't drop immediately. There's enough in the atmosphere for thousands of years, but the long-term outlook is grim. No new oxygen would be produced, and processes like oxidation would slowly deplete it. Humans and animals would face starvation long before suffocation. But it's a reminder, the sun doesn't just keep us warm. It keeps us breathing. Human survival would be a race against time. Power grids reliant on solar energy or fossil fuels would fail as infrastructure froze. Nuclear power plants might run for a while, but they need maintenance and fuel, which would be tough in a frozen world. Underground bunkers with geothermal or nuclear power could sustain small groups, but food would be the bottleneck. Stored supplies might last months, maybe years for the ultra-prepared, but agriculture would be impossible. The atmosphere itself would change. As temperatures plummet, gases like nitrogen and oxygen would start condensing. In about a year, Earth's atmosphere could begin collapsing, with nitrogen liquefying at minus 195 degrees Celsius and oxygen at minus 183 degrees. The air would thin and pressure would drop, making breathing harder, even before it freezes. Eventually, Earth's atmosphere could freeze onto the surface, forming a layer of solid nitrogen and oxygen. Imagine trying to explain that to your weather app. Geologically, Earth would still be active. The planet's core generates heat from radioactive decay, powering volcanoes and tectonic activity. This geothermal heat would keep the deep oceans liquid for millions of years, sustaining tiny pockets of microbial life. But for surface dwellers, it's negligible. The core's heat is only a tiny fraction of the sun's input, nice for deep-sea bacteria, useless for keeping your coffee warm. What about the cosmos? Without the sun, Earth would drift through the Milky Way, potentially passing near other stars in thousands or millions of years. The odds of a close encounter are low. Space is mostly empty, but a rogue Earth could theoretically be captured by another star's gravity. More likely, we'd wander the galaxy alone, a frozen orphan planet. The stars would still shine, but they'd be cold comfort without a sun to call our own. Could life adapt? Some extremophiles, microbes that thrive in harsh conditions, might survive near geothermal vents or deep underground. But complex life, including humans, would face near-certain extinction. Artificial habitats with nuclear power and hydroponics could delay the inevitable, but scaling that for billions of people is a pipe dream. The sun isn't just a light source. It's the engine of life. Without it, Earth would be as hospitable as a snowball in space. Long-term, Earth's fate depends on its galactic journey. In billions of years, the Milky Way will collide with the Andromeda Galaxy, stirring up gravitational chaos. A rogue Earth might find a new star or get ejected into intergalactic space. Meanwhile, the universe keeps expanding, driven by dark energy. In trillions of years, stars will burn out, and the universe will grow dark and cold. A sunless Earth would just get a head start on that cosmic deep freeze. Let's touch on physics. The sun's disappearance defies known laws. Mass energy conservation suggests it can't just vanish, but this is a thought experiment. General relativity governs Earth's orbital escape. Thermodynamics drives the cooling. Biology explains life's collapse. The scenario highlights how interconnected Earth systems are with the sun. It's not just a star. It's our lifeline. Could we prepare? If we knew the sun was about to pull a disappearing act, we might stockpile food, build geothermal-powered bunkers, or launch space habitats. But the scale of the challenge is staggering. Even sci-fi solutions like moving to another star system are centuries beyond our tech. The sun's absence would be a masterclass in how much we take it for granted. So, next time you enjoy a sunny day, give a little thanks to our cosmic heater. It's doing more than you think, and it's not planning to ghost us anytime soon.